Hello everyone, welcome to Pharmacy Lectures by Gopika. In today's lecture, we are going to discuss about tuberculosis, isoniazid, its structure, IUPAC name, synthesis, mechanism of action and uses. What is tuberculosis? It's an infectious disease that mainly affect the lungs. The tuberculosis is caused by a bacterium called Mycobacterium tuberculosis, and this tuberculosis infection spreads from one person to another person through tiny droplets released into the air via cough and sneeze. Drugs which are used for the treatment of tuberculosis is called anti-tubercular agents. Anti-tubercular agents are classified into two: first-line agents and second-line drugs. First-line drugs includes isoniazid, rifampicin, pyrazinamide, ethambutol, and streptomycin. Second-line drugs includes para-aminosalicylic acid, kanamycin, amikacin, ethionamide, prothionamide, and fluoroquinolones. First-line agents are having higher efficacy but lower toxicity, and second-line agents are having higher toxicity but lower efficacy. First-line anti-tubercular agents are having bactericidal action except ethambutol. Ethambutol is having bacteriostatic action. In this class, we are mainly focusing on isoniazid, its synthesis, mechanism of action and uses. Let's see the structure of isoniazid. Isoniazid is also called as INH or isonicotinonic acid hydroside. The heterocyclic ring present in isoniazid is pyridine. Pyridine is a 6-membered heterocyclic ring having nitrogen as heteroatom. Here we have the structure of isoniazid. First of all, we have to number the structure. Here we can see a heterocyclic ring, right? So whenever we are numbering a heterocyclic ring which contain only one heteroatom, the first number is given to the heteroatom and other atoms are numbered either clockwise or anti-clockwise direction. Okay, let's give numbering 1, 2, 3, 4, 5 and 6. In the fourth position, we have a carbohydrazide group. Hence, the IUPAC name for isoniazid is pyridine 4-carbohydrazide. Next is the synthesis of isoniazid, and the starting material for the synthesis of isoniazid is 4-picoline. Here we can see a heterocyclic ring, that is pyridine, and in the fourth position of pyridine there is a methyl group. It's a structure for 4-picoline. This 4-picoline will undergo oxidation in the presence of KMNO4. Thereby, the methyl group present in the picoline will convert it into acid group, that is COOH group. So here we can name it as isonicotinic acid. Isonicotinic acid. Second step is an esterification step. The isonicotinic acid formed will react with alcohol in the presence of acid. Whenever an acid is reacting with alcohol in the presence of acid, that is called as esterification reaction. Here, isonicotinic acid will undergo esterification reaction with ethanol in the presence of sulfuric acid. Thereby, ethyl ester of isonicotinic acid is formed. This is the second step. Next step, the ethyl ester of isonicotinic acid will react with hydrazide. Here we have COOC2H5 group on ester of isonicotinc acid. This OC2H5 group present here will take a hydrogen from the hydrazide. It will be eliminated as C2H5OH, and the remaining NH2 will join here. So that we will get the structure of isoniazid. So that's all about synthesis of isoniazid. First, 4-picoline will undergo oxidation in the presence of potassium permanganate, and the methyl group present in 4-picoline will convert it into acid group, so that we will get isonicotinc acid. The isonicotinc acid formed will undergo esterification reaction in the with alcohol ethanol in the presence of sulfuric acid, and the isonicotinc acid will convert it into ethyl ester of isonicotinc acid, which will further react with hydrazide, and finally isoniazid is formed. Mechanism of action of isoniazid. Isoniazid is a prodrug which is activated by mycobacterial catalase peroxidase, that is CatG enzyme, to isonicotinc acid. Mainly, there are two different target enzymes for isoniazid which is involved in the synthesis of mycolic acid. Mycolic acid is nothing but it's a very long chain beta hydroxylated fatty acid which is found in the mycobacterial cell wall, and it is an essential component of the mycobacterial cell wall. The targeted enzymes are, first one is enoyl acyl carrier protein reductase, that is INHA, and the second one is beta ketoacyl ACP synthase, that is KASA. These are the two targeted enzymes for isoniazid. As we know, isoniazid is a prodrug which is activated to isonicotinc acid by CatG enzyme, and the activated drug is covalently bind to this two enzyme and inhibit these two enzymes which are essential for the synthesis of mycolic acid. So, isoniazid is act by inhibiting the synthesis of mycolic acid. That's all about the mechanism of action of isoniazid. Isoniazid is mainly used for the treatment of tuberculosis. It is having a dose-dependent action, which means at higher doses it acts as a bactericidal, and at lower doses it acts as bacteriostatic. So that's all about the uses of isoniazid.